Hi folks, this is question 4. So first part only asks us for the center and radius. So we should know it'll be the opposite sign. So because it's x minus h, to take it out it becomes just a h, and then it'll be minus 3. So it's there and there are the h and the k, but it'll always be the opposite sign of the way it goes into it. The radius then is, well, the radius squared is equal to 12, so r is equal to root 12. So you can say root 12, you could give it as a decimal if you want, doesn't say. So you're just using that formula, so x minus h squared plus y minus k squared is equal to r squared. That's the general equation of a circle. You should know that anyway, it's in the log tables. Second part, the perpendicular distance from the line to the center of the circle is 5 units. So you have to use this formula, so it's a x1 plus b y1 plus c all over square root of a squared plus b squared. So that's the formula for perpendicular distance of a point from a point to a line. So where the x1, y1 is, it's a point, and the a, b, and c are the line. So here 1 is going to be a, b is going to be minus 4, c is going to be 7, and then your x1, y1 will be, it's to the center of the circle, so that's 0, 0. Oh, sorry. Yeah, your center is h minus 3. So that's it, and then we just sub into that and let it be equal to 5, because we know that the answer should be 5. So a is 1, x1 is h plus b is minus 4, y1 is minus 3, plus c is 7. Stick in our absolute value signs all over square root of a squared plus b squared, so it's going to be 1 squared plus minus 4 squared, and all that will equal 5. So we get h, and then it'll be 12 plus 7, so it'll be 19, h plus 19 all over square root, and it'll be root 17. So that all equals 5. So we can just bring over the root 17 and multiply it, so we get h plus 19 absolute value is equal to 5 root 17. So then we get two values. Just finish over here, so we get h plus 19 is equal to root 17, or minus h minus 19 is equal to root 17. So I can bring the 19 over here, so h is equal to minus 19 plus root 17. That's one scenario. The other is, if I brought the h this side, make it a bit easier, h is equal to minus 19 minus root 17. So those are our two answers. So they wanted the answers in third form, so that's it. So it's just so to the formula. The formula is in the log tables, and then letting it be equal to 5 and just going and solving from there. Right, so part B then was trickier again. Right, so the biggest thing and the most important thing that you have to be able to see here, and it makes life a lot easier if you do, is that the center anyway has to be on this line that I'm putting in. It's a red line. So because you've got the same x coordinate here, you know that that's a straight line up there between those 2 points. So if you look at the y coordinates, this is a 3 and then this is a -5. So what you have to be able to spot is that on that red line there, it'll be halfway between 3 and -5. Halfway between 3 and -5 is -1. So y is equal to -1. And that will have the center on it. So that there is the center. So you know that the if our center is HK, because that's just the general form of the center. Yeah, so if the center is HK, well then the -1 has to be the y coordinate, so with the k. So k is -1 here. So h -1 is going to be the center, and that will give you a starting point then. So that's the important thing to see. If you didn't do that, what you could do is just use the general equation of a circle, the x minus h squared plus y minus k squared is equal to r squared, and just keep subbing in the 3 points. But you've got an a as well, so you've got an extra variable that you need to work out, and you won't quite get it unless you come up with something else that I haven't thought of yet. But what I'm going to do here is I'm going to take these 3 lines, so you've got a radius from each of the points on the circle. So you've got this here, this line here, and this line here. So all of those lines have to be equal to each other because they're all radii of the circle, and they're all going to be equal to √20 as well. So I'm going to take the distance between 2 points, so that's x2 minus x1 squared plus y2 minus y1 squared. And I'm going to use, first of all, I'm going to use a3 and h minus 1, then a minus 5, h minus 1, and then 8, 1, h minus 1. So I'm just using h minus 1 with each of the points and put them into this formula, and we're going to let it equal to √20 each time, because we know that the radius is √20. So first one, I could discard the root anyway, because I know it's going to be √20, and just square both sides and just let it equal to 20 instead. So the first one, it'll be a minus h squared plus 3 minus -1, so plus 1 squared is equal to 20. So I get a minus h squared plus 16 is equal to 20. So I get a minus h squared is equal to 4. So that's an equation I get with a and h in it anyway. Let's use the other 2 points. So I'm going to use the a minus 5 now, so I'm going to get same thing, so it'll be a minus h squared plus minus 5 minus -1, so it's plus 1 squared is equal to √20. I can do the same thing again, just square both sides. It gets rid of the roots on both sides, so I get a minus h squared plus, and it'll be minus 5 plus 1 will be minus 4, so plus 16 is equal to 20. And I'm just getting the same thing here actually. So a minus h squared is equal to 4. So let's sub in the other point then. The other point is 8, 1. So I'll just write up here. So it's 8, 1 and h minus 1. So we get, well, I'll keep the h first anyway. I don't really need to. Yeah, so we get 8 minus, oh sorry, x2 minus x1. Yeah, I'll just leave it at, I'll confuse myself. So h minus 8 squared plus minus 1 minus 1 squared is equal to root 20. So square both sides, so we get h minus 8 squared plus 4 minus 2 minus 2, or sorry, minus 1 is minus 2 squared is plus 4 is equal to 20. And we get h minus 8 squared is equal to 16. So we're getting somewhere here then. I can square root both sides here and I'll get h minus 8 is equal to, and it could be plus or minus 16. Or plus or minus 4 when we square it, I should say. So I'm going to get h is equal to 12 or h is equal to 4. So that's when you're allowing for, so plus 4 plus 8 or minus 4 plus 8. So I have two values for h here. I need to get rid of one of them. So I need just one value of h to put it into the equation of the circle. So I'm going to go back and look at the question. What you should see in the question is that they tell you that a is in between 0 and 5. So you can see it there, I have it underlined. So if a is in between 0 and 5, let's see which of these will not work for them. So I'm taking this equation here that I found, a minus h squared is equal to 4, and putting both of those values in. So the first one, if I put h in, I would get a minus h, well, a minus 12 squared is equal to 4. Square root both sides, I get a minus 12 is equal to plus or minus 2. And then if I add 12 to plus 2, I would get 14. So a is equal to 14. Yeah. Or if I add 12 to minus 2, I get a is equal to 10. So see the way neither of those will work for a, because we know that a has to be between 0 and 5. So we could discard that then, really. We could discard h is equal to 12. Let's just double check that the other one works. So if I put it in, so a minus 4 squared is equal to 4. Square root both sides again, I get plus or minus 2. So a minus 4 is equal to, so well, 4 plus 2 would be a is equal to 6, or a is equal to minus 2 plus 4 would be 2. So this one here works, that one doesn't work either, but a equals 2, so we know that a has to be 2 then. So you can go all the way back here, so a was always 2 then, so 2, 3 and 2 minus 5 are on the circle. So h is 4, so final answer then after all that. I'll put it into the equation of the circle, so x minus h squared plus y minus k squared is equal to r squared. So we get x minus h is 4, we said, has to be 4 now, plus y, it'll be minus 1, so that'll be plus 1, squared is equal to root 20 squared will be 20. So that's our final answer.